So in this video we'll be looking at the proof of the cosine rule. So we want to end up with this formula right here, and we're going to look at how we get there using this non-right angled triangle. So obviously the capital letters inside the triangle are the angles, and the smaller letters outside the triangle are the lengths. So we can see that capital A, its opposite is small a, capital B, its opposite length is small b, and capital C, the angle down there, its opposite length is small c. And we're going to just go through some Pythagoras and prove how we come up with this formula. So let me just put a line through here, which is perpendicular to line B. We're going to call this H, okay? So now we've got two right angled triangles. So if it's a right angle there, it's obviously a right angle down here. All right, and we're actually going to go do some Pythagoras. Now before we do that, I'm going to call this length over here x, and this length over here would be b minus x. Okay, so the whole length minus x. So let's go through and do some Pythagoras. Okay, so let's go use our Pythagoras formula, a squared plus b squared equals c squared, and find what we have here. So let's do this triangle first. Okay, we'll do this triangle first. Okay, so we have a squared, which is the hypotenuse, is equal to h squared plus b minus x squared. And next we will do this triangle over here. We get c squared is equal to h squared plus x squared. Alright, now what I will do over here is I'll take this x squared across the other side, so it becomes c squared minus x squared equals h squared. And I'll take this part over here and replace it with the h squared right there. So I'll come down over here. So you got a squared equals c squared minus x squared plus b minus x all squared. And we'll expand this b minus x squared. I'll come and do it on the side over here, so it's easier. So we have b minus x multiplied by b minus x. We go through our method of FOIL. So first value, so b times b is b squared. Alright, then we go for the outsides, so that's negative bx. Then we do the insides, that's negative bx again. And then we do the last, which is positive x squared. So we get b squared minus 2bx plus x squared. And we can replace that with the b minus x squared right there. So we get a squared equals c squared minus x squared plus b squared minus 2bx plus x squared. And now we just go and add like terms. So we can see we've got negative x squared plus x squared. Well, that just cancels out. So we're left with a squared equals c squared plus b squared minus 2bx. Now, if you look at that, we're quite close. We're quite close. So the only thing we're missing over here is the cos A, or c cos A. So what I could do is I'll actually look at triangle 2 again. Alright, and I'm going to use my cos. So katoa, I want to use the ka part over here. Okay, so I'll do it in a different color. Let me see. We'll do it in yellow. Okay, so do it on the side over here. Just got a little bit extra space. So we got cos of A, that's this A over here, equals the adjacent, which is x, over the hypotenuse, which is c. And we can rewrite that as c cos A equals x. And now I can take this and replace it with x over here. Alright, so I get a squared equals c squared. I'll just probably write it as b squared plus c squared, like it alphabetically, minus 2b, and x is now c cos A, c cos A. And that right there is our cosine rule. Okay, now this rule is good when we're finding a side, because a, small a, is a length of a triangle. Okay, so this rule is really good when we're finding a side. However, there's another rule. Okay, and that one looks a bit like this. cos A equals B squared plus C squared minus A squared over 2BC. And to get here, we will just rearrange this formula. Okay? To get here, you just need to rearrange that formula. Again, I'll show you that really quickly as well. So if we've got A squared equals B squared plus C squared minus 2BC cos A, I'll take this lovely thing over here with the negative to the other side, and I'll bring this to the other side. So I'll put it, this goes across that side of the equal sign, and that comes here. So what I will get is I get positive 2BC cos A equals B squared plus C squared minus A squared. And then all I will do is divide both sides by 2BC, and my final solution is cos A equals B squared plus C squared minus A squared over 2BC. And we've got our second formula as well, which helps us find a missing angle. Okay, so this is how we find, or this is the proof behind the cosine rule.